Alright, this is another video, the final video for section 6.2 through 6.5, and it's more ideas on similarity. Now, we've already talked about parallel lines and how they set up a proportion, that the sides have to be in a proportion, how we can set up scale factors, and how we determine scale factors and set up similarity statements. We're going to take this a step farther, and we're going to solve some different types of problems that either use similarity or proportions. Alright. This first idea deals with perimeter. It says if two triangles are similar, then their perimeters have the same ratio as their sides. Okay? What this means is that if I know two triangles are similar, I can figure out what the scale factor is, that ratio. Remember, I take one side and put it over the other side, the corresponding side of the other triangle, make a fraction out of them. This tells us that the perimeters have that same fraction, that same ratio. So we're going to do an example. It says the two triangles are similar. What is the perimeter of triangle XYZ? Notice we have triangle RST here, and we have triangle XYZ, and XYZ only has one side given. It doesn't have all three, so we can't figure out the perimeter. We can't add everything together because we don't know the other two sides. What we can do, though, is use a proportion to solve this. First thing you want to do is figure out the perimeter of triangle RST. Now remember, the perimeter is when we add all of the sides together. So we would take 22 plus 28 plus 30, and we end up getting 22 plus 28 is going to be 50 plus 30 is 80. So the perimeter of that triangle is 80. We're looking for the perimeter of this triangle, and that's what we're finding. So we're going to start by doing the perimeter of the big triangle. We're going to put the big triangle in the numerator and the small triangle as the denominator. Big triangle's perimeter is 80. Small triangle, we don't know. This is perimeter. That's going to equal the same ratio as the sides. Now, only one side is given in the small triangle. It's this one here that's 11, and that corresponds with the 22. So we're going to make a ratio, make a fraction out of those. The trick is figuring out what goes on top. Remember, we started with that big triangle in the numerator, so we have to go back and put 22 as our numerator in the other ratio, because the big triangle needs to stay on top. And then 11 in the denominator. Now we have a proportion. We can solve this. It's a pretty easy proportion. We have to cross multiply and divide. Let's go ahead and start cross multiplying. 22 times x is 22x equals 80 times 11, which is going to be 880. I'm going to divide both sides by 22. So 880 divided by 22 ends up giving us 40. So x is 40. That tells us the perimeter of the small triangle is 40. Alright? And that's how we would solve that type of problem. We set it up just like we normally would if we were going to find the sides or something along those lines. But we only have one side given, so we set up a ratio for the sides and then a ratio for the perimeters. Our next idea deals with what an angle bisector is, and we've talked about this before, but we're going to refresh our memory. An angle bisector divides or cuts an angle into two equal parts or pieces. Okay? Same thing. So if I had an angle here, my angle bisector would cut it into two equal pieces. That's what we're talking about. Now our big idea says an angle bisector in a triangle divides the opposite side into segments that have the same ratio as the other two sides. A lot of words there. It's very simple to figure out, though, and I'm going to show you with a picture. This is our angle right here, the angle we're talking about, and this is our angle bisector, the line that cuts it into two equal pieces. We know we have an angle bisector because these two angles are marked congruent. Okay? Now what happens is that angle bisector becomes your fraction bar for your fractions. So what we end up having, that's our line, this is our line here, which means we have A over D and B over C. We set them equal to each other. There's our proportion. And that's all we have to do, and then we would solve it from there. Okay? Pretty simple. You just need to make sure that you have the side that gets split, the ones that I have underlined here, B and C, they make a fraction, and then the other two sides make a fraction, and they get set equal. Just make sure that if I started with A, that means I need to start with B on the top, okay? Whichever direction I'm going. Now we're going to look at an example here. We're going to do one example, and we're going to call it good. Our example here, we're going to determine X. Now notice we have an angle bisector. We know we have an angle bisector because those angles are marked congruent. So this line here, our angle bisector, becomes our fraction bar. I'm going to start over here with x plus 6. X plus 6 is going to go over x. And the reason is those aren't on the side that's getting split into two. Okay, those are the other two sides of the triangle. Equals, well, I started here, so I need to start here with 8. So 8 is my numerator, and then 5 is my denominator. Now we have our proportion. We're going to go ahead and solve it. Again, setting this up, we want to make sure we use that angle bisector as our fraction bar. Now I will say you can't have this flipped. I could have x over x plus 6. That's fine. That means I would start on the left. That's okay. I started on the right though, so I need to continue to start on the right for both of my fractions, both of my ratios. Okay, let's finish this. Let's cross multiply. 8 times x is 8x, and 5 times x plus 6 needs to be written like this because we're going to distribute. 5 times x is 5x, and 5 times 6 is 30. That's got to equal 8x. Subtract 5x from both sides. 8x minus 5x is 3x equals, those canceled and we're left with 30. Divide by 3. So x is 10, because 30 divided by 3 is 10. Now again, it doesn't ask us for the sides of the triangle. It only tells us to find x. It doesn't actually say, but we're just going to stop at finding x. If it did tell us to find the sides of the triangle, we would plug our answer back in to get the sides of the triangle. Now that's how you solve problems with an angle bisector. Again, it's not very difficult. You just need to remember that the bisector becomes your fraction bar when you set up your proportions. And if whatever side you start on, top, bottom, left, or right, you need to continue to start with that when you set up both fractions. All right, that's your video for sections 2.3 through 2.5. It's the last video. So if you have any questions on this particular video, go back and watch it again or bring them to class. And if you have any questions on any of the videos, be sure to go back and watch any of them and see which one will help you solve your question. If you still have questions, be sure to bring them to class next time.